Creating partial fractions allows you to write a rational expression as the sum of two or more simpler rational expressions. But how is this done? Well, the first step is to factor the denominator. As we can see, the denominator of the left side is equal to x minus 3 times x plus 2. So how do we make that equal to simpler fractions? We write the denominator x minus 3 as one of the denominators of the first rational fraction, and we don't know what its value is in the numerator, so we place a simple a in the numerator, a constant. And we're going to write the second denominator, x plus 2, in the numerator. We don't know what that will be either, so we write a b. So we have a problem with constants over factors. Now, since these factors aren't repeated, we don't have to worry about the second step here. And neither of the factors, neither of the denominators is a quadratic, so we don't have to worry about the numerator being a linear function. So now it's simply a matter of simplifying. If we are simplifying an equation like this, that means that we're going to multiply everyone by the denominator of the original. So if we multiply the left side by x minus 3 and x plus 2, we get x plus 7. If we multiply a by x minus 3 and x plus 2, we're going to have a times x plus 2. The x minus 3's will cancel. And if we multiply b by that common denominator of x minus 3 times x plus 2, b will be multiplied by the x minus 3. Now, before you get crazy and multiply everything out, let's pick some easy numbers for x that are going to make things disappear for us. An easy number for x would be to allow x to be a negative 2, because we'll get a 0 here and a will disappear. So if x is negative 2 plus 7 will be equal to 0 plus b times, x was a negative 2, so negative 2 minus 3. So 5 is equal to b times a negative 5, so b is negative 1. Let's pick an easy number to make the b go away. If x is a positive 3, we'll get a 0 here and b is gone. So 3 plus 7 will be equal to, allowing x to be 3, 3 plus 2 times a. So if 10 is equal to 5a, a has to be 2. So now we're ready to rewrite our equation. The x plus 7 over the quantity x squared minus x minus 6 is now equal to a over the x minus 3 plus b over the x plus 2. Here's a second example. If we want to write x minus 6 over x squared minus 4 as a partial fraction, we need to factor the denominator into x minus 4. We need to factor the denominator into x minus 2 and x plus 2. So that will be equal to some number over the x minus 2 plus another number over the x plus 2. So when we want to clear out the fractions or the denominator, we're going to multiply by the common denominator, the least common multiple, x minus 2 times x plus 2, and we'll get x minus 6 on the left-hand side. And if we multiply a by x minus 2 and x plus 2, the x minus 2's cancel, we'll get an a times x plus 2. And AB times the x minus 2. Again, pick convenient numbers that are going to make this easy. So let's make x equal to a negative 2. So the a will go away because 0 times a is going to be 0. When x is a negative 2 minus 6 is going to be equal to 0 times 0 plus b times negative 2 minus 2 is a negative 4. So b becomes 2. Again, pick an easy number for b to go away. What makes b go away? Well, we'll make a 0 here, a positive 2 for x. So subbing 2 in and everywhere for x, 2 minus 6 is a negative 4, and a will be times 2 plus 2, which is 4. So a in this case is going to be a negative 1. So we simply rewrite this as my a over x minus 2 plus the b over x plus 2. In this third example, write the numerator 5x squared plus 20x plus 6 over the factor denominator, x times x plus 1 quantity squared. So this is a situation where we have a repeated factor, so we'll have to include the lesser powers of the factor. So this is going to be equal to some number over x plus another number over x plus 1 plus a third number over x plus 1 quantity squared. So if we multiply everyone by our least common multiple, we'll get 5x squared plus 20x plus 6 is equal to a times the x plus 1 quantity squared plus b times the x times x plus 1 plus c times x. So what's going to make this easy? Well, if x is 0, the b and the c go away, and we're left with 6 equals a times 0 plus 1 is 1, squared is 1, so a is 6. Now let's let x be a negative 1. Negative 1 squared is 1, 1 times 5. Negative 1 times 20. Negative 1 plus 1 is 0, 0 squared times a. We'll get a 0 here, and c times negative 1 is negative c. So we have a total of a negative 9 equals a negative c, so 9 equals c. So we have two of our variables. How will we get b? Well, unfortunately, there aren't any other really easy things to try. So let's pick a nice number like 1. Because we've tried negative 1 and 0, so let's pick 1. 1 squared times 5 plus 1 times 20 plus 6 is equal to 1 plus 1 is 2, 2 squared is 4, plus 1 plus 1 is 2 times 1 is 2 times b, plus 1 times c. So we have a total of 25, 31 equals, we know A is 6, 4 times 6. We don't know what B is, but we know that C is 9. So we have 31 equals 33 plus 2B. Subtracting 33 from both sides, negative 2 equals 2B, so B is a negative 1. So our new equation will say our partial fractions are 6 over x plus a negative 1 over x plus 1 plus a 9 over x plus 1 quantity squared. Here's a fourth example. We'll take 3x minus 1 and put it over the factor denominator of x times x squared plus 1. Notice that in this situation we have a quadratic in the denominator. So that means that the numerator has to be linear. So we'll rewrite this as some number over x, as we have been. But we also need a linear factor in the numerator, so bx plus c is linear, and we'll put that over our quadratic. So when we multiply both sides by the least common multiple, we get 3x minus 1 is equal to a times x squared plus 1 plus bx plus c times x. So let's pick some nice numbers again. If x is 0, all of this goes away. So 3 times 0 minus 1 will be equal to a times 0 squared plus 1 plus 0. So negative 1 is now equal to a. So let's pick another number. We aren't left with a lot of nice choices, but let's let x be 1. That means that we will have 3 times 1, or 3 minus 1 is 2. 1 squared is 1, plus 1 is 2, so 2a. 1 times b plus c, all times 1 is still b plus c. And we know that 2 times negative 1 will eliminate the 2a. So b plus c has to be equal to 4. So one more substitution should help get us to the point where we can eliminate a b or a c. So let's let x be negative 1. Still a small number, should make it a little bit easier. So when x is a negative 1, we're going to get 3 times a negative 1 minus 1 equals a, or negative 1, times negative 1 squared, which is 1, plus 1 is 2, plus negative 1 times b, plus c, all times negative 1. So 3 times negative 1 is a negative 3, minus 1 is a negative 4. Negative 1 times 2. And we'll have a negative 1 times a negative b plus c. So plus b minus c. If we bring that negative 2 to the other side, we will have a positive 2 on this side, so negative 2 equals b minus c. And this equation, 4, equals b plus c. So we can eliminate c's by adding the 2 together, and we will get 2 equals 2b. So b has to be 1. And once we know that b is 1, what 1 plus what equals 4? C equals 3. So our equation becomes, or our partial fraction becomes, a, which we said was negative 1, over x, plus b, which is 1, times x, plus c, which is 3, all over x squared plus 1. Here's one final example. We'll rewrite this as 3x squared plus 4x plus 4 over x times x squared plus 4. So once again, we have this quadratic for the denominator, which means that we'll have to have a linear numerator. So we'll have some number over x plus a bx plus c over our x squared plus 4. So when we multiply by our least common multiple, 3x squared plus 4x plus 4 will be equal to a times the x squared plus 4 plus x times the bx plus c. Now this is one time when we will multiply everything out because it will make simplifying things a lot easier. For the simple fact that when we have a quadratic equal to a quadratic, the leading coefficient will have to be equal to the coefficient of the x squared over here. The 4 that's being taken times the x will have to be equal to whatever's taken times the x on the other side, and likewise the constants will have to be the same. So we'll have an ax squared plus 4a plus bx squared plus cx. So if I write that descending powers, I will have an x squared times this a plus b plus a cx plus my 4a. X squared, x constant. Rewrite that. That means that 3 has to be equal to a plus b. Likewise, 4 has to be equal to c. And finally, 4 has to be equal to 4a. So a is 1, and 3 is equal to 1 plus b, so b is 2. So rewriting our partial fractions, we will have a 1 over x plus 2x plus 4 over x squared plus 4.